Hi scientists! My name is Joy.
And my name is Yaz.
And we are here in another Nature Memoirs Online class.
Yes, today it's all what's the matter?
What's the matter with you?
No, what's the matter?
I'm good. What's the matter with you?
No, what's the matter is the name of the class.
Oh, what's the matter is the name of the
Yes.
class. So what are we learning today?
Well, today is all about chemistry and how it has to do with matter.
That makes sense. Are you guys ready? Let's go! Matter. You know what is matter?
No, what is matter?
Okay, so matter is everything that takes up space and has a mass.
Like
You-
this
That's made out of matter.
and this.
Yes.
And what about me?
You are made out of matter.
And the air?
Yes. And the planet,
Really?
and the sun, and the stars, and the animals, and the plants. Everything is made out of matter.
That's a lot.
Yes, and that's what we're gonna be learning about today. Okay, Jasmine, do you know what science study matter?
Yes, it's chemistry.
So we're gonna be chemists.
Yes.
Ooh, I like this. Okay, so and what specifically does chemistry study?
Now, chemistry studies matter, but matter has to do with the smallest particles, which is atoms and molecules.
What is the difference between an atom and a molecule?
Now, an atom is a single particle. It's a building block to everything.
Okay, and what is a molecule?
Molecule is more than one atom. So if we take two atoms and we put them together, we're gonna get a molecule.
But how tiny are molecules?
They're actually very, very small. But it's better if I show you how small they are.
Okay.
So I have this tablespoon here. I'm going to take some water. I'm gonna fill this tablespoon. Now, in this tablespoon of water, just this tablespoon, there is 600 billion trillion molecules.
Okay, let me see if I can repeat that number. 600 billion trillions molecules
Yes.
of water.
Yeah.
And you said that molecules are made out of two or more atoms.
Yes, so there's even more atoms.
I don't even want to ask how many, okay? There's way too many zeros.
I know.
And that's why we have so many different types of matter depending on the atoms and molecules that they are made out of. Okay, so today we're going to be talking about 5 different states of matter. Do you know that there are 5 different states of matter?
5? I thought there were 3.
I thought that too, but no. Actually, there are 5 different states of matter. Do you know what are the most common ones? Yes.
Yes, solid, liquid, and gas.
Okay, but I have to tell you, there's 2 more states of matter.
2?
Yes, one is called plasma, and another one is called BEC.
BEC.
There is boson-Einstein condensate. We're going to be talking about solid and liquid and gas later on, but plasma is a gas that has been super heated up, super hot, so much that the atoms separate and then you have positive and negative charges in this gas.
Equal amounts?
Equal amounts, but the cool thing is because they are separated, they can conduct electricity. So it's like a charged gas. That's what
Wow.
plasma is. So do you know what's BEC?
No, what is that?
Okay, it's the opposite. It is when you have certain substances that you cool down to almost absolute zero, which means super cold. And what happened with the atoms, they get so close together that they form a super atom. But then today we're going to be doing 3 different tiny experiments of the most common state of matters that are
Solid, liquid, and gas. Now the experiments that we're going to be doing have to do with thermal expansion.
wait up. 2 big words. Thermal and expansion. Okay, thermal has to do with temperature.
Yes.
And temperature is the measure of kinetic energy in a substance.
Yes.
And you said that kinetic energy is the movement in the substance. So more kinetic energy, higher temperature. less kinetic energy,
Lower temperature.
Expansion is kind of like to grow in size.
Yeah.
So we're gonna grow on size substitute just adding temperature?
Exactly.
Okay, that's crazy. Okay, let's start with our first state of matter, which is solid. Are you guys ready?
Yes.
Let's go. Okay, Jasmine, what is a solid?
So a solid is a fixed shape. All of their particles are tightly packed together.
Okay.
So there is not a lot of movement. They are very attracted to each other, which is why they have this fixed shape.
So because there's not a lot of movement and the attraction is so high, they stay together.
Exactly.
Always the same.
Mhm.
Like a solid relationship.
Yeah.
Okay. Can you show me?
Now, here we have some solids. This is just a regular little cylinder. If we put it in this beaker,
It's still a cylinder.
yeah, it doesn't take the shape of the beaker, it's still the same. Now, if we put it in this Erlenmeyer flask,
It's still the same cylinder.
yes, it doesn't change. Now, if we put it in this graduated cylinder,
It's still
still the same. Now, that's because of how strong the attraction is with these particles. They're so attracted to each other, they keep their fixed shape.
Okay, and that is what is a solid. So, what are we gonna do with our thermal expansion in a solid?
Now, we're going to take this metal ball and
Okay.
this metal ring. We are going,
Are they solid, Jasmine?
oh yeah,
Wow. Yes.
definitely solid.
Yes, they are.
Now, we're going to take the temperature of this metal ball.
I have a thermometer, and
Perfect.
actually, I have a digital thermometer. Okay.
Fancy.
So I'm going to turn it into Fahrenheit, and I am going to measure the temperature of this metal ball.
Perfect. Now, what we're going to do is we are going to take our Bunsen burner here
Okay.
and we are going to start a little flame and we're going to take our metal ball and we are going to heat it for 3 minutes.
Okay, so we have the timer here and start for 3 minutes. Time is up. So it was around 70 degrees before. Let me see what is the temperature right now. Oh my goodness, Jasmine.
Very, very hot.
Okay, so so because it's hot, it's more kinetic energy.
Yes.
And the molecules are moving more.
Yes.
So you're telling me that it's gonna get like bigger?
Well, it's not getting bigger, it's expanding. It's still the same mass that it was before, but because we increased the temperature and the rapid movement of the molecules, we have an expansion.
Expanded. Okay, so let's see if it fits through that thing now.
Now, if we try, it doesn't fit. And I can try really, really hard,
Okay, no, you're gonna break it, Jasmine.
but it
So-
doesn't fit.
Okay, so thermal expansion, matter is not created
Or destroyed.
or destroyed. So still the same matter, still the same mass, but it's just expanded. Question. Heating it up, it make it expanded. What happens if we cool it off?
If you cool it off, you're slowing down the movement, which is going to make it contract.
Ooh, steaming.
And now it fits again.
That was really cool. Thermal expansion in a solid.
Yep.
How can we apply thermal expansion in our day-to-day life?
In a solid specifically,
Mhm.
if you look at a sidewalk, now these sidewalks have cracks in them.
Yes, that actually, there's
Yeah.
like little blocks.
It's not a solid piece of concrete.
No, it's not.
They're always separated.
Yes.
And this is due to thermal expansion. It gives them space. If they're expanding, they need that little bit of space. If not, we would have these concretes cracking.
so the engineers know this.
Oh yeah, of course. With building anything, they have to keep in mind thermal expansion.
It's not a crack just to have a crack, it's just to give the space for the molecules to expand when it gets super hot.
Exactly.
Thermal expansion in a solid.
Perfect.
Applicable to our daily life.
Yeah.
Okay, so next one is gonna be liquids. Are you guys ready?
I'm ready.
Okay, Jasmine, now we're gonna do thermal expansion, but in a liquid. You explained that in a solid, the molecules are very attracted to each other. They're almost touching each other, super, super close. Their movement, kinetic energy, but it's less. In a liquid, there's still some attraction. These molecules still touch each other, but they're not so close. Okay?
Wow.
The attraction is less than in a solid. That is the reason in a liquid, which is this water, since liquid, the liquids, they have a shape, but the shape that they have is depending on the solid that is containing them.
Wow.
For example, this beaker has more like a cylindrical shape.
Yes.
And my liquid is what?
A cylinder.
Okay, now look at this Erlenmeyer flask. It's like a triangular type of cylinder, right? When I put my liquid in there, what happened with my liquid?
It kind of turns into a little triangle.
Exactly, it takes the shape of the Erlenmeyer flask. Now, if I take my liquid and I now transfer it to a graduated cylinder, guess what happened?
It turns into a cylinder.
Exactly, because liquids, the molecules and their attraction, they still have some attraction, but it's a lot less. Okay,
Wow.
that's the reason they don't have a definite type of shape. So, the experiment that we're going to be doing today is also related with thermal expansion. Now, over here, we have two different liquids. One that is cold and one that is boiling. So we are going to be using two different food colors. We're going to be using
Red for hot
and
blue for cold.
blue for cold. We're going to apply 3 drops of food coloring to both liquids. One that is cold. What happened with the molecules in cold, Yasmin?
Well, they're slower.
They're slower. What happened with my molecules in something that is hot?
They're faster.
Exactly. So, thermal expansion explained that higher the temperature, the expansion is faster, right?
Yeah.
So, are you ready to start?
I'm ready.
Okay.
Wow, yours filled very, very fast.
Mine is already all red.
But mine isn't blue yet.
No, it's not. This to our day-to-day life. The easiest way to describe it is using a thermometer. Okay, we're not going to be using the fancy one. We're going to be using one that actually has a liquid inside. So what happens with the liquid in a thermometer is with higher the temperature, the liquid is going to expand and it's going to go up. Okay, and with less temperature, the liquid is going to just contract and it's going to just get low. You ready to see it?
I'm ready.
Okay, so let's start with the hot liquid that we just prepared.
Oh my god, it's shooting up so fast.
Okay, so it's still the same amount of liquid because matter is not
Created or destroyed.
there you go, but it is expanding because the molecules are moving faster. Now if we put the same liquid now in this colder water, look what happened.
It's going down.
It's going down because the molecules are moving less, it's less kinetic energy, the temperature is lower, and just the liquid is contracting, so it's kind of like shrinking.
That was awesome.
That was really good. I'm ready for our third experiment, which is about
Gases.
let's do this!
I'm ready.
Okay, Jess, we're ready.
Yes.
Now it's all about gas. What is gas?
With gas, it is a state of matter that can't really be contained.
No
All
shape.
of the particles in a gas are moving freely and rapidly. They're nowhere near each other.
And there's more kinetic energy, you're
A
saying?
lot of kinetic energy.
Okay, so can you contain gas?
Well, you can only contain gas with a solid.
Okay, Jasmine. Yes, yes. Exactly, that's exactly my point, guys. I don't like balloons because they are unpredictable. What just happened?
Well, all of the gas was contained in the balloon, but I let it go, and now the gas is free.
So you're telling me that all your breath is freely right
Everywhere.
here in the lab. Okay, that is a very vivid example of gases.
Yes.
They cannot be contained. They're constantly moving. Kinetic energy is higher, and there's no attraction among those.
Nope.
They just want to be free.
Exactly.
Okay. Hold on. We're going to be doing an experiment with gas
Yes.
and thermal expansion.
Yeah.
Now I'm curious. What in the world are we doing?
Now, with the gas, we're going to take this Erlenmeyer flask that, as you can see, has a balloon on the top.
Yasmin, it's empty.
But that's the point. When we heat it up, there's more kinetic energy.
Okay.
They're moving rapidly.
Yes.
This is going to cause the inflation of the balloon.
Okay. Go ahead. I want to see thermal expansion.
Okay,
With
perfect.
the balloon.
So we're placing it on our hot plate, which is going to heat up our Erlenmeyer flask,
Okay.
and it's going to inflate the balloon.
So that water is going to turn into gas.
Yes.
And that gas is going to get crazy, just like the balloon that was flying around here.
Yes.
And Yasmin,
It's already inflating.
Yasmin, that's crazy.
The kinetic energy is increasing, so this is causing the expansion.
Of the balloon.
Yeah.
Okay, question, Jasmine. If the temperature is increasing the size of the balloon, if I lower the temperature, is that going to decrease the
Yes.
expansion? Because I really don't want that to explode.
So now we're going to take our Erlenmeyer flask with our inflated balloon,
Okay.
and we're going to put it in ice cold water. And as you can see, it deflates immediately.
Oh, Yasmin, it inflated backward.
Yep. The sudden change in temperature and change in kinetic energy created this vacuum that sucked the balloon to the bottom.
Okay, I have to admit, the first time that I really like balloons. Okay, Jazz, we talk about state of matter. We were chemists today, okay? And we discussed that chemistry is the study of the smallest particle of matters that are called,
Atoms and molecules.
there you go. Then we talked that matter has 5 different states, okay? We talk about solid,
Talked about liquid.
gas,
We talked about plasma.
and one that I didn't know that it was Bose-Einstein condensate. 5 different states of matter. We did 3 different experiments.
With the solids, we talked about thermal expansion.
Okay, we also talk about thermal expansion. In liquid, higher temperature, makes it very fast.
Lower temperature takes a little bit longer.
still not mixing.
Yeah.
And we talk about gas. That was
The
my
coolest
favorite.
one.
Okay, I do not like balloons, but your experiment was really, really cool.
I know. We talked about how thermal expansion will cause this balloon to inflate, and then the change in temperature and kinetic energy will cause it to deflate.
There you go. So 3 different experiments.
Yep.
And all about thermal expansion and chemistry. But this is only part 1. We have 2 more parts of this What's the Matter chemistry lesson, and we're going to be discussing that in the next videos. So what should we do now?
Well, now you guys should like and subscribe, and make sure to tune in for our next video. And remember to
Discover the truth in nature's voice. Bye, scientists!